A quote from Neil deGrasse Tyson states, "What makes Proxima B interesting is that it is an Earth-like planet orbiting the closest star to the Sun." The James Webb Telescope has now taken the clearest image ever of a planet so similar to Earth that scientists can only marvel. Proxima B is only about 4 light-years away from us and could be the first exoplanet that we humans explore with probes. After the shocking news about this planet, researchers are building many spaceships to check who lives on Proxima B and whether these beings are friendly. Proxima B is an exception among exoplanets. This planet is only a little more than 4 light-years away from us, making it one of the closest celestial bodies in the universe that is not part of our solar system. The Proxima Centauri system has puzzled scientists for centuries. For a long time, Alpha Centauri was thought to be our closest stellar neighbor, but then surprises kept happening. First, scientists found out that Alpha Centauri is not a normal star at all, it is a double star. A few decades later, this mysterious system in our immediate galactic neighborhood surprised us again. Modern astronomers, using ever-improving telescopes, found anomalies in the Alpha Centauri system that amazed them. Finally, researchers discovered the reason for these anomalies: a third star. However, this third star in the Alpha Centauri system did not appear to be simply a companion to the already known star duo. The star was and is too conspicuous for that. Although its orbit is directly linked to the other two stars, Proxima Centauri wanders far beyond the orbit of the other two during its travels through the cosmos. This led scientists to realize that the third star could be trapped. The gravitational pull of Alpha Centauri A and B has captured this third star, and since then, the three have been dancing a cosmic dance. The exoplanet Proxima Centauri B was discovered in 2016 as one of the first near-Earth exoplanets, and the find was a sensation. The James Webb Telescope is now revealing the true nature of Proxima Centauri B. Proxima Centauri B could be the closest planet to Earth that is inhabited, which is incredible because we could even visit this world in the not-too-distant future. Proxima Centauri B would certainly be one of our first destinations when we are able to build interstellar spaceships. But we have even more exciting facts about this. First, let's take a look at the wonders of this planet, which is considered an Earth twin. Proxima Centauri B is a bit bigger than Earth and a bit denser. It has been clearly identified as a rocky planet, which means that, unlike gas planets, it has a solid surface throughout. Proxima Centauri B orbits its star in a very close orbit, so that a year on the planet lasts only 11 days. At first glance, this doesn't sound very habitable because, close to a star, it would be very hot, at least in our solar system. But in the Proxima Centauri system, it's different. The star is not as luminous as our Sun, which clearly puts Proxima Centauri B in the habitable zone of its star. If the planet also has water, it could truly be an Earth too, with a mild climate and life. This is exactly where the James Webb Space Telescope comes in. Although the planet has been known for many years and there has been much speculation about its true nature, our technology could not determine whether Proxima Centauri B has an atmosphere and water. The goals of the Webb mission are clearly to find out these facts, not only with regard to Proxima Centauri B but also with regard to many other potentially Earth-like and inhabited exoplanets. Webb can use its unique technology to create the first exact analyses of the environment of distant planets. To do this, the telescope uses a completely new type of spectrometer technology that works with infrared light instead of visible light. Infrared light rays can also be emitted by very distant or very weak celestial bodies, or rather, the light shifts into the red color spectrum due to the long journey to us. What Hubble, which works exclusively with visible light, could not do, the James Webb Telescope can now do with ease. Even the faintest signals from distant stars that have traveled billions of light-years are captured by this new super telescope and converted into visible images. In the case of exoplanets, the technology provides us with precise data from a planet's environment on a cosmic scale. Exoplanets are like grains of sand or dust, they are tiny compared to their stars and cannot emit their own light. However, they reflect light, and scientists use this to track them down. Imagine how an exoplanet first absorbs the light of its star, then it mixes with the planet's atmosphere and is reflected from the surface. All the light that we perceive on Earth, giving us pleasant warmth, is sunlight that has been absorbed and reflected in this way. During these processes, the light from the Sun is changed, and Proxima B changes the light from its star. If the light mixes with certain gases in the atmosphere or even promotes the reaction of the gases and heating processes, it emits a fine but still perceptible light spectrum. This spectrum contains hundreds or thousands of different light waves, and each gas and element produces a unique signature. Its own universally recognizable signature within the light spectrum, in plain language, means that oxygen in the environment of Proxima b produces similar wavelengths to oxygen in the environment of Earth, and the same applies to the finest water droplets in the environment of a planet. Depending on how much water is measured in the planet's environment, scientists can then draw further conclusions about the amounts of water on the planet's surface, a habitable water world with continents and life. Would you ever have thought that there are other habitable planets in the universe, or were you one of those people who firmly believed that we are the only ones in the universe and that the Earth is unique? To come straight to the point, there will never be a planet that exactly resembles Earth. There aren't even two snowflakes that are exactly the same, but there are some planets that are pretty damn similar to Earth, and Proxima b is one of them. According to science, a true super-Earth is a bit bigger, a bit warmer, and a bit heavier than Earth. Such a planet would contain large amounts of water and have harmoniously distributed land masses. The climate would be temperate and evenly warm, and the star would have about twice the lifespan of our Sun. During this longer lifespan of the system, supercivilizations could even form according to evolutionary researchers, and it's precisely such civilizations that we hope to find in the universe. Imagine we have a highly intelligent and technical society somewhere in our galactic neighborhood which, on top of that, is friendly and interested in contact. We could probably learn a lot from such creatures. At the moment, this still sounds like a long way off, but engineers and scientists are working every moment to master interplanetary and ultimately interstellar space travel to Proxima b in just 20 years. If Yuri Milner, a Russian billionaire and space enthusiast, has his way, spaceships will be flying to Proxima b in just a few years. The first of these mini spacecraft will only have a camera and some minimalist measuring instruments on board. However, the equipment should be sufficient to provide us with the first real photos from the Proxima system and finally show us whether or not Proxima b is inhabited by life. Thanks to a unique acceleration technology, the probes, which are only a few centimeters in size, will travel at almost the speed of light and reach Proxima b in a period of less than 10 years. We could see the first photos of an exoplanet as early as the mid-2030s. We will see the planet's atmosphere and colors for the first time, and it will be a surprise to see whether Proxima b is blue, green, and white like our Earth, or brown, black, or even red. Thanks to measurements from the best telescopes on Earth, we know that Proxima b probably has a bound orbit around its star. It has a day side and a night side. The day side is probably too hot for life, and it never gets dark there. The night side is always dark and probably very cold. The interesting thing about this planet is a transition zone that stretches once around this world, and life could be possible there. It sounds crazy to us that a planet is habitable only on a strip of several thousand kilometers, and on one side, it goes either into eternal brightness and heat, and in the other direction into darkness and cold. That wouldn't make the planet a true twin of Earth. In our search for other life in space, we must also allow for other possibilities of life and forms of life that go beyond our previous definitions. This, of course, raises the exciting question of whether we would then also be able to visit Proxima b ourselves. Yes, many scientists are certain that as we continue to advance the current state of technology, we will soon be able to construct spaceships with engines that can reach almost the speed of light. Trips to Proxima b would then probably be possible in about 20 years. However, we still don't know how we will overcome problems such as weightlessness in the universe or the effects of cosmic radiation. All hopes in this regard are pinned on the development of the warp drive. This is supposed to enable travel through the space-time structure of the universe without the need for fuel. In theory, the drive, which we all know from science fiction films like Star Wars, already exists. So far, however, we have been stymied by the energy problem, but here too, there is constant encouraging progress. In 2022, researchers from the USA succeeded in creating a mini-warp bubble. This bubble can stretch spacetime in such a way that material objects, such as spaceships and people, can simply slip through a fold for travel over vast distances. We would then need hardly any time and comparatively little fuel. We just have to be able to create such a bubble on a large scale, and that will cost energy. The solution would lie in alternative energy, such as negative matter or even the mysterious dark energy. If the warp drive is successful, we in space travel will not only be free of time and space, but space travelers would also be free of the stresses of cosmic radiation or effects such as time dilation. Subscribe now to the channel. We are constantly publishing new, exciting videos.